Yes.
So our total IP addresses are divided into 5 classes: Class A, Class B, Class C, Class D, Class E, and star. Again, the Class A, Class B, Class C are unicast addresses, which we can assign to our devices. Out of this entire ranges, again, the 0.0.0.0, we cannot assign to any device. And same for 127.0.0.1, we cannot assign to any devices. And entire 0 series and entire 127 series, we cannot able to assign to any devices. Of course, we cannot use D and E also. Okay. So we are assigning IP addresses class A, class B, class D ranges. And these IP addresses are divided into 1 second, guys. Yeah. No problem, sir. Class one. I can sit. Okay, just move forward. 1 second. Just can you able to hear? Just put a headphones. My voice is there. And mic. Okay. I think it is working. Okay. So the IP addresses are divided into network portion and host portions. So I given this example for a earlier example. It is just before that when I had given these examples, right? Like a what example? Network portion and host portion. Okay. So here it is. For example, you are in an apartment. Apartment numbers are like this, like 101, 102, 103. Represents one represent it is a floor number, it is a door number like that. Okay. The same way in the network, you have a devices are connected, and if you want to make sure that it is their network portion is must be same. Okay. In the network IP address, we have a network portion and host portion. The host portion is different to actual identification of each and every device. Like this is 1, this is 2, this is 3, 4, 5, like this. It makes all the devices based on the network number belongs to this network and belongs to this specific network. And this is the host identification. Okay. And here it is, you can see how this is a different thing. Okay. So here it is by default. By default, we divide the IP addresses based on the class into a network portion and host portions. if you take a class A IP address, the first portion is network portion, remaining are host portions only. Remaining are host portion only. For example, you take 10 as network. 10 is a network portion and remaining are host portion. So for first system, I put a 10.0.0.1. Second system, I put a 10.0.2. So third system, I given 10.0.3, 10.0.2.4, and another system I given a 10.1.3.6. No problem. Why? Because of network portion is different. Only important is if all these systems having same network ID or not. Remaining is host IDs. Okay, that is the class A. What about a class B? By default, the first two portions are network portion. It means it must be same for entire network, and the remaining portions are host portions. For example, you take 172.16.0.1. That is a I given a IP address to a system. Okay, and this is our network portion. This is our host portions. Okay, and second system I given 172.16.0.2. 172.16.1.5. 172.16.2.2. 172.16.2.3. So what is the most common? It is that it is same network or not. In case I given like this 172.17.2.4, still it is a different network because there is a different network portion is there. Difference in the network portion, either first one or in a second one. See, it is a different. So these are all devices can able to communicate each other because their network portion is same. And these devices cannot communicate to these devices.
Explain this part again.
Yes, very good. Very good. Okay. 172, right? 16.0.1. This is I assigned to one PC. And second PC I assigned like this. All the network portion is 170.16 only for all these five PCs. Network portion is 170.16 only. It means all these devices will communicate each other in the same network. So they will communicate communicate each other. Okay. In case there is a sixth device, I given a IP address like this. It won't communicate. Why? Because of it is a different network. This is same network, but this is different from here to here. It's again different network. For example, here I given like this. Okay, this is different network. So these two devices cannot communicate to these five devices. This device won't communicate to these five. This device cannot communicate to these five, and these two are not communicate each other also. So why? Because of there are different networks. Okay. So because of class B is a the first two portions, network portion, it must be same for all the devices. Host portions can be different. Either place can be only one difference or multiple differences can be there. Either one difference or a multiple differences. See, like this also no problem. Either one host part is different or a multiple host parts can be different. Okay, got the point now?
Yes.
Very. Again, class C. First three portions are network portions only. And the last one only host portion. See, if you see first three portions are network portion, last one is host portion. So same, I will write here. So because paintbrush, the clumsiness, that's why you are confused. Okay. So I'm giving 192.168.1.1. This is my, I assigned to one device. 192.168.1.2. 192.168.1.4 or 192.168.1.5. Okay, these four devices can communicate each other because of their network portion is same and host portion is only one single host portion that is different. 192.168.2.6. This is different network. This is different network. 192.168. 169.1.7. This is different network again. Even one of the octet is differ from other automatically. It is different network. These three are different network from this network. Okay. So what is a network? The network portion in the IP address must be same for entire your logical network. Either you use class A means the first octet must be same for all the devices. If device want to communicate in the network, network means in a local network, in a local physical network it is. Okay. So if devices want to communicate in a network, that's it. Okay, not to do different networks in a network. So their network portion must be same, and host portion can be different. Can be different means either one portion of a network host portion or two or three host portions can be different. Okay, either only one network host portion is different, or two host portions are different, or three host portions are can be different. That's why I said can be different. Means host portion is different and network portion is must be same. Devices are in a same network can communicate each other means their network portion must be same. Devices are in same network means their network ID must be same. These three are just like an important guys. Whenever you are in the network, either you are doing some cloud network or maybe if you are in some local network or maybe in a WAN network, two devices are directly communicating each other means their network portion must be same. There is a two devices are communicating each other directly. Okay, it means their network portion must be same. Then only they will communicate each other. Okay. So here I given an example PC1, PC2, PC3. Which class of IP address it is? So very good. It is a class A and network portion is first octet is a network portion. Remaining are a host portions. So this PC1 and PC2 having same network portion and there is a small change in the only one single host having a different host portion. Okay. So it is both can communicate each other. PCC, there is a different network address. See, it is 110, it is 111. It means PC3 cannot communicate to PC1 and PC2 also. And here it is 181. It is which class it is? Class B. First two portions are network portions. See, these two PC1, PC2, PC3 are having same network portion and with a small difference in a host portion. See, here it is to here, only one host portion is different, but here it is two host portions are different, but still these three are communicate each other. But if you see this one, here it is different network address. This is from different from here to here. is a difference. From here to here, it is a difference. So these two are cannot communicate it to these two machines. Same goes for class C. You have to check class 3, first three portions are same or not. We cannot communicate. So PC1, PC2 can communicate, but PC3, PC4, PC5 cannot communicate it to 1, 2, 3 as well as each other also. The entire host portion should not be same in the same network. At least one host portion must be different. That's it's I've written instead of writing here. So at least one host portion. Okay, here it is one host portion is different. Here it is two host portions are different. Both are good. How host portion it is. Okay. Guys, understand the network portion and host portions of IP address?
Yes.
Okay. I'll give you one more example here instead of rolling so many differences. So 192, 168, 2 data, 1, 172, 168, 2 dot 2, 192, 168, 2 dot 3. Three systems are there. 192, 168. Yeah, not required. We have this one. These two are, so look at only these two networks. This is one network, this is another network. How it is become another network? Because there is a network address difference is there. Here it is a 1, here is a 2. Okay, both are different networks. So these three systems can communicate each other. These four systems can communicate each other. But these systems and this system cannot communicate each other directly. If you want to make them communicate, we need a router. Okay. So normally, if you are configured all these 3 plus 4, 7 systems in same LAN, they cannot communicate each other. Okay. Means this network cannot communicate each other. Okay. So we divided them logically. And one more point is there, guys. So we'll take this example as not this one. This is a better example. I will take it. One more example. I will take it like this. See, I have a 5 systems I configured with this IP addresses. And I found the PC4 is unable to communicate to PC3, PC2, PC1, and as well as PC5. And I find that PC5 is also not communicating to anyone, or anyone is not communicating to PC5 also, and PC4 also. Where is the problem? Why PC4 and PC5 are not communicating to PC3, PC2, PC1? What is the problem here?
Different network.
Yes, different networks. For example, there is a 5 systems are given to you, and your admin is telling configure an IP address. You are a network in the network group. Okay, you are a network administrator. So like you are joined freshly and you know the IP address. The administrator said this is the network you should configure, and you configure to the 5 devices, and later 5 devices, 2 devices are not communicating to anyone. Then you are find it is a mistake. Okay, you check the IP address. So the two things in the network, guys. First thing is connectivity. If not communicating means, is there is a connectivity? There are not. And the second one is IP address, right? Test ping. So you are not getting ping replaced correctly. It means first is connectivity. Physical connectivities there are not. And second one is IP address is correct or not. IP address must be in the same network. And you find it is not in the same network. Then what you will do? You configure manually. So what you will do? You'll change it. Understand? You do a mistake.
Yes.
What we will do? We'll correct the mistake. So can you see? And here it is. Now all are in the same network. And another important one is compulsory check the host portions also. Here all the host portions means the host portions are different. No, it's a good one. No problem. Just in case the host portion is also same. What happen? Conflict will be generated. Okay. So then if conflict is there and check the host portions also. Okay. So we corrected the network portion and check the host portion, and host portion, at least one of the host portion must be different from others. Okay. So this is good. For example, one more example for a to reduce the another point, because you are understanding, that is a good thing. It is you're not speaking, but you are understanding, that is a good thing. 23 and 25 or 23. Is it generating any conflicts? No conflict. Why? Because of, so it is a different host version.
Sir, if
Maybe,
any one block have a different number, so it's a network.
yeah, in a network version, if any one of the block is, any one of the portion is different, that is different network. That is different. In a host, any one is different, it is good. Okay, no problem. Okay. You have to make sure that both host versions not same. Okay. But it is a difference is there. So
Right now,
it is a
sir,
good to go.
they all are in same network, na?
They are in same network. Now all are in the same network. Okay. And different host IDs.
The last two is host ID, na? 24, 25, 24,
Yeah,
25.
that these are host IDs. Very good. Here also I written one more additionally, right? This is also host ID. Okay. So you understand what is a network ID and what is a host ID. You take an IP address and you understand this is the network portion and this is the host part. You understand by default given, right? But how system can understand? You are giving an IP address, and how system can understand this is my network ID and this is the host ID, when if it is communicating to another system, is both are in the same network or a different network, how they will understand, how they will understand this, what is the network ID or a network portion it is. Okay. It is based on the subnet mask. Okay. So we have to give an IP address as well as a subnet mask. Using this subnet mask, your system will calculate what is the network portion, what is the host portion, what is its network ID. By default, the class A, again we write a class A, okay, it's a 0 to 127, class B, class C, only three. Why? Because of unique cache addresses which we can able to assign to our devices. So 128 to 2, sorry, 191, 192 to 223. This is class. And here it is, first portion is network portion, remaining are host portions. By default it is. And first portion is network portion and remaining is host portions. First three are network portions, remaining is host portion. So what is this subnet mask. Actually, it is also look like an IP address. It is also is a kind of stuff. It is like this subnet mask actually represents your network wise kind of stuff. Means it helps your system to understand what is your network ID. It divides your IP address into network and host portions. Subnet mask actually divides your network into host portion and network portion. So this is our network. Okay. It is a by default subnet mask of class A, by default subnet mask of class B, by default subnet mask of class C. If you see where is a net 255 is there, so there is a network. So two networks, 255s. Three first are three networks, so three 255s, and it is follows from it. Actually, the network portion. So it is the network is represented by ones and a host represented by zeros. You can, if you want to go in depth, you can also write like this. So the first portion is network portion means it represents with ones like this. This is the class A subnet mask. So it is represented with ones. So 8 ones means 255. This entire portion is ones means this entire portion is network portion. Okay. So what is the subnet mask? Subnet mask divide your IP address into network and host portions. It tells network ID of IP address. You have an IP address and a subnet mask from your using your subnet mask. Okay, it divide your IP address into network and host and tells the network ID. If a network ID matches, they will communicate each other. I have written that point also. Devices are in the same network means their network ID must be same. Okay, network ID must be same. Again, how system will understand what is the network portion and host portion and what is the network ID of it. So using a subnet mask, that system will divide an IP address using subnet mask. System will divide. Actually, the sentence should be like that. Using subnet mask, system will divide your IP address into network and host portion and find a network ID of an IP address. If network ID matches between the devices, they will communicate each other. If not matches, they won't communicate in the direct network. It means direct local network. It cannot able to communicate. Okay. So it is a class A, class B, and class C. And this part again, I will explain, guys. What is this? I will explain it again. Understand, guys, what is a subnet mask? What is the use of subnet mask? System use
Sir,
subnet mask to divide IP address. Yeah, tell me.
sir, sir, can you scroll it up?
This side or the downside?
Yes, yes, wait. So, sir, this 255.255.008 is IP address. And
No, no, it is a
255.
subnet mask. It is a subnet mask.
Scroll up, sir, scroll. This is IP address
Uh, yeah,
2.181.24.24.2.
these are all IP addresses.
So, sir, we can also write in this form like 1011010000101110.
Binarily also you can write.
Why we are doing? Then why we are changing it? Is it for just for
Uh,
reading purpose,
yeah, it is really direct
user friendly purpose?
yeah, user friendly purpose. We cannot how a normal person easily understand. How can you tell this much big number 1010? You will forget a zero or one, something misspell. Also, it is danger, right?
Earlier, I'm not understanding that in starting you said that the IP address of IPv4 is a 32-bit number, and how
Yes,
can I
this is
able to make
32.
it? Then that time I'm not understanding why we are just using it. Then when I saw
Okay,
earlier,
okay. It
then
is
I
32 bit,
found that
but how many small
we are
numbers are there?
converting it in decimal
In
format.
yes, convert into decimal format. Right. Exactly. Very good. Okay. Yeah. Right. Okay. So, yeah. Guys, these are the subnet mask by default of a class A and class B and class C. But how system can able to calculate? You give an IP address, you given a subnet mask. How system can able to calculate? It use a logic gate called a AND gate operation. If both the bits are zero, then output is zero, or any bit is zero. See, it is here is a zero zero, here is zero, here is a zero, but output is zero. Even 0 1 0 1 0 0. If both are one, output is one. Okay, it's like this. It happens with like this. Um, yeah, cancel it, and I will open another one. Okay, I have 1 0 1 1, and in the down second one is 1 1 0 1, like this. So I'm calculating like 1 1 AND gate operation 1 1 0 0 0 1 again 0 and 1 1 it is 1. Okay, it's happen always like this. This same thing I take like this. All are zeros in another side. 1 0 again 0 1 0 0 0 0 0 0 0. This is the output. You take like this. If you take all are ones in a B side, 1 1 1 1 0 1 0 1 1 1 1 1 1. So same it is repeating here. Here it is zeros are repeating. Here it is some number is came. Okay. So it is three representations. Like I am showing three examples. Okay. It is a AND gate operation. Means if both side one are there, you will get a one. Anything is zero. Either it can be a zero or it can be a one. You will get a zero only. Okay. So that is the point of AND gate. Okay. In the subnet mask, ones represent network bits. Ones represent network. Zero represents host bits. You take 255 means all are ones. Zero means all are eights. Eight zeros. 255 means eight ones. Guys, there is a network here. It is a one network. It is I have written. I will point out again here. So look at here. Take an example of a network means what. So this is a network. Think like it is a network. This is a starting. This is called a network ID, which we cannot assign to a device. Can't assign to a device. We use it, but we cannot assign to any device. The network ID is can. That is the first one. But or actually we can is able to assign from 0.1 only. Okay, which is actually the first valid IP which we can assign to a device. And it is follow up like this. Like I have a first system, I assign 0.1. Second system 0.2. Third system I assign 0.3. Okay. So fourth system I assign like this. Okay. Fifth system, sixth system, seventh system I assign one by one. And finally, I have a system like a 254. This is the last valid IP. Up to here we can able to assign 1 to 254 we can assign, and 254 5 is also there, right? So this is called a broadcast ID, okay, which we cannot assign. I put a spelling wrongly. Assignment. Okay, GN. GN. Okay. So natural hand typing. Okay. So what is the next number after this one? By naturally, what is the next number? This is the next number, right? 255 completed, 1.0. So this is, see, different network it is. It is a different network. This is another network ID. It is not in the part of this network. Means you have a devices, 100 devices are there. You assign an IP address from here to here. We can assign any of the IP address from here to here. We can assign, and all are communicate each other. Up to 254 we can assign. Okay. But if you assign this one, this is a different network now. It's outside of network. Again, this follow different sequence. So again, it is 1.1 start. It goes up to 1.255 and 2.0 is another network. So this is called entire one single network. And this first one we call it as a network ID. The last one we call it as a broadcast ID. Okay, broadcast ID. So in a one single network, we cannot use two IDs. One is network ID we cannot assign, broadcast ID we cannot assign. In between that, all IP addresses we can use, we can assign to any device. We can assign to any device. Okay, understand guys that point? I'm waiting. I have to go for lunch and I will tell only one last point. Okay. Then remaining we will explain tomorrow. Up to here, understand, guys.
Yes.
Okay. Good. How to find a network ID, I will tell. Okay. I will explain this one and I will close today. Okay. Compulsory read once more, guys, because you are seeing all these things for first time. And definitely for first time, for my understanding, for me it took 2 months for self calculation of subnet mask calculations and all. Okay, so these are all your first time you are looking at. It is take time. Okay, so in a class C, this is a class C, right? This is a class C. This is a network ID, this is host ID. From 1 to 254 I can use it. So totally 254 systems I can assign it. So what is the host portion? One host portion. One octet it is. It's a complete one octet, means 8 bits. 2 to the power of 8 is 256. Minus 2. Why minus 2? Two IP addresses we cannot assign. One is the very starting one, that is a network ID, and very last one, that is a broadcast ID, we cannot assign. In one single network, in a one single complete network, we cannot use two IP addresses. One is network ID, another one is broadcast ID. That's why minus 2. And what is the result? 254. It means, for example, in my network, one single class C network, in single class C network, I can connect up to 254 devices. It same goes for a class B. C, host portion is 2. By default, host portion is 2. It means this is 8 bit, this is 8 bit, totally 16 bit. 2 to the power of 16 minus 2. Why minus 2? Network ID, broadcast ID. So we cannot use it, minus 2. Remaining entirely, we can use it. The total it is 265,534 valid host IP addresses you are getting. So if you have a network It is a very big one. 65,534 devices can be connected in single class B network. Single class B network. The same goes for class A. See, 3 host versions. It means 8-bit, 8-bit, 8-bit. Totally 24. 2 to the power of 24 minus 2. It is 16 million. So you divide like this: 16,777,214 number of devices we can connect in a single network. Okay. You want to see as it is like this. If you take a class B, example 170.16.0.0. Again, this is a network ID. Okay. Network ID. The very first IP address is 0.1. 172.16.0.2. Keep goes 172.16.0.254. 172.16.255. 172.16.1.0. All are valid IP addresses only, nothing like that. Okay. 172.16.1.1. It keep on goes up to 172.16.255, 254, 172.16.255, 255. This is our broadcast. Why broadcast? If you see, what is the next one? Can you tell me what is the next one? 172. This is, now it is another network. Okay, from here to here, it is a single network. This is our last valid IP. This is first valid IP. This is last IP. Means in this entire network, this is the first one, and this is, so this entirely we can able to assign to all hosts. The total number of IP addresses from here to here, if you are write everything one by one, it is 65,534 IP addresses. Okay. So it same goes for a class C also. Like take a 10.0.0.0 to 10.255.255. Yeah, I will write. This is a network ID. 10.255, 255, 250. What is it is? Our broadcast ID. Okay. So what is the next one? This is another network. And what is the just before this one? This is the last one. And what is the first one? Okay. So this is entirely one network. From here to here, if you write one by one addresses and you count it, it is 16,777,214. 16,777,214 number of IP addresses. We will get it. Okay, guys, understand the calculation, what I am showing calculation. So network, total network ID, valid IP addresses, broadcast IDs.
Yes, sir.
Very good. So here it is. Think like this. You have a network. For example, in your organization, you have 100 computers only there. Only 100 computers. And your admin, your boss asked you as your network admin, you ask which class of IP address is suitable. Which one you prefer, A or B or C? You said which is suitable, A or B or C? See it, number of hosts per network. I have only 100 computers. Which you will prefer? From class A or class B or class C?
Class
Class
A.
C.
Okay. Class A, class C. Okay. So here it is 254. Here it is 16,777,214. Here it is 65, 5,054, 34. So if I choose this one, how much I am wasting? 154 IP addresses I am not using. But if I am using here, it is 100. So 65,434 number of IP addresses I am not using. Which is better, right? This is better, right? Like that. For example, my boss added another 100 computers. Which is better? Again, still it is better. For example, my boss added another 200 computers. Which is better? Maybe you have a 400 computers and you have to pick up a one class from it. Which is better? Which class is better now? Very good. Class B is better. And you have a 5,000 computers and you have to pick up one class. Class B is better because still 65,000 it is. Okay. 60,000 still it is left. 60,000 computers. Still class B is better. 70,000 computers. Then you will go for class A. See, this is the one of the reason we are dividing IP addresses into classes to best utilization of our IP addresses also then based on the our subnet mask. And we divide them into the logical portions, like why one portion is network portion, why it is in another place, and host portion is so like that. Why divide them into network and host portions? We can best utilizing the IP addresses. In single class C, we can able to get connected 254. And here it is also I have written in this class C, I can able to use in this network, I am getting 254 devices can be connected. In this network, 254. In another, 254, like that. In this one, 65,000. In this one, 65,000. Like that, I can able to. This is almost like 16 million above. I can able to connect it. Okay. This is the reason why network is the IP addresses are divided into classes and IP addresses again further divided into network and host portions based on the classes and by default conversion. Why I use the by default means there is another way is also there. So that is the point. Okay. Up to here we discussed, guys. Remember, this is how to divide network portion into IP address into network. So you take an IP address and subnet mask, and we will get a network ID. So that is also I will tell you what is the meaning of subnetting. I will tell you. I'm not showing any subnetting calculations. Okay, what is a subnetting? I will tell you how representing is now subnet mask with a slash notation. That is also we'll going to discuss. Okay. And tomorrow, that is we are going to discuss tomorrow. And also we are going to discuss what is private IP address, what is NAT and PAT. Then we have a time, so then also we'll discuss about the OS layers. Okay. For now, that's it for today. And another important one is I want to tell guys, I forward two videos to you. One is about IPv4 and IPv6, and another is public and private IP addresses. Okay. And already I think I told to the channels to you. So this channel is PowerSet animation channel. Okay, you will get the channel name from the videos itself. So you can go to this, what is this playlist. There also you can get what is the modem and router differences, hub and router switch differences. Okay, what is wireless access point and Wi-Fi router, like this. What is a DNS? What is a NAT? What is DHCP? What is IPv6, IPv4? What is APIPA, ARP? Like that, VLAN, subnet, TCP, UDP, ping command, traceroute command, different topologies, WAN, LAN kind of stuff. Okay, fewer differences. 2.5 now it is more famous, right? Most of the routers are dual band kind of stuff. 2.45 gigahertz Wi-Fi's are there. What is the difference? It is, so you have a time, so go through once, what are the requirements, what are your doubts, lot of things, everything is less than 10 minutes only, almost like 8 to 10 minutes videos only. Better to go and understand. Even you can go for what is a proxy server, what is VPN server, okay, okay, what is a default gateway, what is a subnet mask. See, there is a useful lot of information is also available. Only thing is, my point is, you must learn and you should have an idea, so then you can able to understand and you can able to speak about it. Okay guys, from
Yes,
here
sir.
we'll discuss tomorrow. That's it for today. So don't waste time, improve your technical skills. So whatever the